In this step-by-step guide, I'm going to show how to run correlation and regression analysis in JASP. I'm going to open a data existent in the library, the big 5 personality traits. So let's have a look at the data first. We've got 5 numerical variables, which are measures of neuroticism, extraversion, openness, agreeableness, and conscientiousness. And so we can go first to descriptives. And we can put all the variables. And then we've got here the mean, standard deviation, minimum, maximum for each of the variables. If we do plots, we can have box plots for the individual variables. We can add the jitter element, which is the data. And we can have the violin. I don't like to have the violin and box plot together, so I remove the box plot. And you can use color as well. Okay, so now when we want to have the correlation, the scatter plots, we just press here. We're going to do without an intensity on the sides. And without regression line at the moment. So here we've got the correlations or the scatter plot or combining the 5 variables. Now, if we want to add regression line, we just press add regression line. Well, it has a smooth line. I don't like the smooth line, so we get the linear regression. And the gray area is the 95% confidence interval. Okay, so another option for correlations of several variables is the correlation plots. And that will show a combination of a distribution plots here with correlation, the scatter plots, but all together in the same graph. And here they are. So this is so we've got neuroticism, extraversion, openness, agreeableness, and conscientiousness as rows, and neuroticism, extraversion, openness, and agreeableness and conscientiousness as columns, and we've got the corresponding scatter plot. And then we've got, when we've got the 2 distributions, so the 2 variables connect, instead of showing a scatter plot, it shows the distribution in a histogram. Now that's enough for the descriptives. Let's go to regression and correlation to obtain the correlation. So we can put again all the variables, and we've got the Pearson's R correlation coefficient, and it reports significance. So this is a typical correlation table in which it provides the correlation of the variables on the left with the variables on top, and the p-value, it indicates well, to test whether that R score is different than 0 or not. So here we've got the R and the p-values, and we can have to flag the correlations that are significant. So here we put 1 star or asterisk to probabilities lower than 0.05, 2 stars to probabilities lower than 0.01, and 3 stars to probabilities lower than 0.001. We can have scatter plots here as well, which is the same as what we saw in the descriptives. Okay, so let's move now to regression. Let's consider we want to, so first let's go to linear regression now. We want to predict neuroticism based on the other 4 variables. And here we've got a regression. So here we've got the coefficients. This is for a model that only includes the B0, so the intercept. Then this is the model that we proposed. In this model, the intercept is 5.5290, which is the level of the dependent variable neuroticism expected if the other variables in the regression, the predictor variables, the value is 0. So when we have 0 extraversion, 0 openness, 0 agreeableness, and 0 conscientiousness, the value that corresponds to neuroticism is 5.5290. And then all these values are the bit 1, or the slope of the regression. So that's what's minus 0.445 is the expected increase, which is negative increase, or it is a decrease in neuroticism as a function of the increase of 1 unit of extraversion. Here, for openness, is this unstandardized coefficient, means that for 1 unit of increase in openness, we expect a 0.12 units of increase in neuroticism. For agreeableness, for 1 unit of increase in agreeableness, we expect a 0.0995 units of decrease in agreeableness, neuroticism. And for conscientiousness, for 1 unit of increase in conscientiousness, it is expected a reduction of 0.3878 units of neuroticism. This is the standard error, and this is the standardized coefficients. The standardized coefficients are calculated by first transforming all the variables to z-scores. So we do that by subtracting the mean of all the values in all the variables, and then dividing by the standard deviation. So the new variables are all values with a mean of 0 and a standard deviation of 1. And when we do that, we've got these slopes. And the slopes now, instead of being measuring units of the raw variables, it is measuring standard deviation units. So here extraversion negative 0.3486 means that for 1 standard deviation increase in extraversion, it is expected a decrease of 0.3486 standard deviations in neuroticism. And then we've got a measure of the R-square of the model. So the R-square of the model is 0.2536. We can see that by the sum of squares. So if we have the sum of squares of the regression, which is 25.9317, the sum of squares of the residuals is 76.3, and the sum of square total is 102.2358. So when you do 25.9 divided by 102.2, that is 0.25. So R-square is the amount of variance accounted for by the regression model.